Good day everyone, I am Remelin M. Damot. Now I am going to present my proposed algorithm in cryptography subject entitled Code Cipher, a modification of Caesar cipher using ASCII code as a key. In my base cipher, Caesar cipher is one of the cryptography that hiding a message, and to hide a message it uses a shifting key. In my modification, Caesar cipher using ASCII code as a key. In this cipher, when we encrypt, the plain text was converted to the position number on the alphabet, and the key was converted into the decimal on the ASCII table, and their values was sum, and the total was modulus to 26. Why 26? 26 was the number of characters that alphabet have, and the result of modulus was converted into the appropriate letter on the alphabet, which is the result is the ciphertext. This is the block diagram of Caesar cipher procedures of encryption and decryption. In the encryption, first we create a plain text. I create a plain text of we pass, and I use a key of LS3. LS3 which move 3 letters to the left to get the ciphertext, which A becomes X and so on. Then we can substitute the plain text on the appropriate ciphertext below. W becomes T, and E becomes B, and so on. And the result of the ciphertext was TBMXPPBA. Now we are going to decrypt this ciphertext, and I use RS3 to decrypt this ciphertext. First, we are going to move 23 letters to the right. We move 23 letters to the right. It looks like the ciphertext in encryption. I use a different key to get the same plain text. So now T becomes W, B becomes E, and so on until we get the plain text of we pass. We pass. In my modification, first we create a plain text which is we pass, and the ASCII code is the key which is thinking. After we create this, we convert plain text to the position number on the alphabet. So W becomes 22 in the position of the number height of the alphabet, 22. Then E becomes 4. Then ASCII code or the ASCII was converted also into decimal position on the ASCII table, which T, the lowercase of T, is equivalent decimal is 116, and so on. Then we add or we sum the values of plain text to the values of key. Then the total was modulus 226 to get the result or our ciphertext. This is the modulus procedure, and this result was converted to the alphabet letter. Letter number 8 was letter I. Number 4 was letter E, and so on. This is our ciphertext. In the decryption of my modification, first I use ciphertext of IEQGBTKC. Then I use a key, yes, the same key. I use the same key of word thinking. Then, like what the process of encryption it looks like in the decryption, we convert the plain text into the value position on the alphabet in the key, the decimal position, the decimal in the ASCII table, which is this, and this is the value of the plain text. Then now we can subtract this value to get the total. Then we modulus it to get the result. And the result is i-convert naman natin into sa alphabet, like sa encryption we convert to the alphabet, and the result was we pass. Why it happened we pass? Because 22 becomes W. Number 4 is letter E. So I get and so on until we get this plain text we pass. My Python code. In Python code, it shows how my modification encrypt and decrypt. This is the implementation of my modification. Let's use the Spider app. Spider app I use to implement my modification. Version 5, Spider version 5. In this Spider app, I have already a code to use. First, I create a dictionary to get the position of character in alphabet and to get the characters by its position. In this code, the key was repeated until the key length is matches to the message length. Here in implementing encryption, this includes converting characters to the index, also perform of adding the value of the plain text and the key, and modulus procedure also. Then also perform converting to the letter by its position. Here in the decryption, this is the same process to the encryption, but it subtracts their value. In this part, user choose between E and T. If the user enter the E letters, it means encryption, and T to decryption. In my code, the plain text or ciphertext to be entered is on uppercase, and the key is enter uppercase, lowercase, or special characters because the key was get on the ASCII table. Let's try to encrypt. Let's try to encrypt. First, the user want to encrypt, so choose letter E. Then enter a plain text. Look what I said, it uppercase. So I entered my name, Remilin. Click enter, then enter the key. So the key was either special character, lowercase, or uppercase because it is on the ASCII table. So I use a key of special character. So this is my key. Then enter. Then this is the ciphertext of Remilin using this special character as a key. Then now we try to decrypt this. I decrypt this ciphertext. Then let's see if the plain text or the original text is Remilin. Let's see. Let's to decrypt. So I enter D. Then I copy the ciphertext. Copy. Then paste it here. Then enter. The key was the special character, so we use the same key. Then this is the original text, Remilin. So it success. So let's try another example. Try to encrypt. So we put in enter. Then I use plain text of we pass. Then the key I use is the in lowercase. Thinking. Click enter. Then this is the result or the ciphertext, like what the result of my last presentation or the current presentation. This is the same. Then let's try to decrypt this ciphertext, and let's see if we pass is the original text. Enter letter D to decrypt. Then let's copy. Let's copy this. Copy. Then paste it here. Enter. Then the key was lowercase, which is the thinking. Enter. Then this is that. The original text was we pass. So again, it's successful. So this is the end of my implementation in the Python app. This is the end of my video presentation. Thank you.